Now we have seen how we can price a perpetual American call. Let's now take a look at how we can price a perpetual American put. Now, again, the approach is very similar, where we need to find this or express the solution, the price of the perpetual American put, as a function of a particular level. And if we were to reach that level, we will exercise. Then we then determine what the optimal level is, and substituting that particular level, we'll get our price. Now, in this case, because it's American put, we should be looking at the direction where the starting point of the stock price is higher than this optimal level. So when it has gone lower and went across the level, we should, this becomes the optimal exercise level. And given in this case it's American put, it does make sense to actually exercise it earlier. And so, as soon as the stock price is lower than that age, we should exercise. Now, even for American call, it's only the case that the underlying stock does not pay dividends that we should wait forever. It was never optimal to exercise it. If we have a stock that underlying stock that does pay dividends, even for American call, as soon as they go across that optimal level, if the actual stock price is higher than the optimal level, we should actually exercise as well. So more so for American put, and there's no such case that we don't exercise until maturity, which in this case is perpetual. So let's take a look at it, how we can price that. The boundary conditions are when we exercise, we'll obviously get K minus H. And we know in this case, the stock price is equal or less than H, and H obviously should be smaller than K, okay? And if S was to go approaching infinity, then our value of the perpetual American put should approach 0, okay? Well, if you look at the options for American put before this price, then this price will also give you a condition that as stock price were to go to 0, your value of the option should also be 0 as well. And you should actually see that from this equation here. Because when S is equal to 0 and alpha is greater than 0, this whole expression becomes 0. Okay, so check out that. So similarly, for American ones, we should derive an equation such that if we were to have S approaching infinity, we should see that the solution tells us the price of the perpetual American put should approach 0. So let's take a look at it. Well, we say that for the partial differential equation we're talking about, which is the same partial differential equation, but with a different boundary condition here, this solution satisfies the PDE and also the boundary condition. And where alpha takes this term and W takes this particular term as well. Okay, here notice that this is minus alpha, whereas for the and here is K minus H. So for call, you actually have H minus K, and there's alpha here, okay? but for the put, it's K minus H, and with a minus alpha here. Now, we obviously also need to find the optimal level of H, okay? So essentially, we go through the same approach. You should go through that exercise to determine this optimal level of H. Now, we're just gonna show that if you have done that, you would have seen that H is equal to, the optimal level H is equal to K times alpha divided by alpha plus 1. And you can plug this in, and you will get this put equation, which is equal to this. Now, you can see that because alpha itself is positive, and we have a minus alpha, which will give us a negative power here, then when S is approaching infinity, indeed, this P will be approaching 0. So that means it satisfies the boundary condition that way. So here we now know the value of the perpetual American put, expressed in terms of all the things that we would know. Basically the current stock level, the strike price, and interest rate, dividend, and volatility. Okay, and that gives us all the information we need to price it.